Welcome dear students. This is the first lecture, I can say not a lecture, this is a presentation. First presentation of your practical exercise. In the course Elect Agron 311 Agricultural Waste Management, this is the course of BSc Agriculture degree program in 5th semester. This is the elective course you have opted to study this course. Here in this lecture we will see what is pH. Every time when you study soil science, when you study waste management, when you study agronomy, or you have studied in last semester irrigation water management, while assessing the water quality, pH was the important factor. Every time we used to say this should be the pH of soil, this should be the pH of water, this should be the pH of your compost or everything whatever we use in our agriculture. So this pH words you have come across through the course, through this word, but it is very necessary to understand the clear-cut meaning of pH, what the pH depicts, why pH is important, and how the pH is being measured, whether it is soil or it is water or it is any other material which is associated with water. pH is to be measured. So there is a method, fixed procedure to measure the pH of any material. Basically the pH of liquid material or the pH of aqueous solution. It is being measured. So these are the points which I will cover today here in this discussion. So first we will start with pH. pH is the measure of hydrogen ion concentration. Hydrogen ion concentration means where? Means in a solution. In a solution or in a water, our salts are present in ionic form. So what is the concentration of ion in that concentration of hydrogen ion in the solution? It is the indication of pH. So this concentration of hydrogen ion in the solution tells us that whether the solution is acidic or alkaline. So this pH value basically indicates that it is the acidic solution or it is the neutral solution or it is the alkaline solution. So this is depicted by pH. This is the formula of pH which is given by the Sorensen, Peter Lorentz Sorensen in 1909. The formula is pH is equal to minus log hydrogen ion concentration. Means the reciprocal of log of hydrogen ion concentration in a solution is the pH. So here log is the logarithm of 10 base 10. Its base is 10. There is one more logarithm, that is e base logarithm. This is 10 base logarithm. So you have studied this in mathematics, but 10 base logarithm is a very simple logarithm. H ion. So H ion concentration, how we measure the hydrogen ion concentration in our solution? So it is measured in terms of moles. So hydrogen ion in moles in per liter solution. So that is taken here. So this is minus log H ion concentration. Means if the H ion concentration is more, the pH value will be less, and as hydrogen ion concentration will be more, means the solution is acidic. If the hydroxy ion OH minus hydroxy ion concentration is more, means hydrogen ion concentration is less, the pH value will be more because hydrogen ion concentration is less and it is the minus logarithm. So this way pH is being calculated, and this pH is the measure of alkalinity and acidity of a solution. So pH simply means power of hydrogen. This is the meaning. This is the abbreviation which is written as, it is always written as like this, small p capital H. It means power of hydrogen, or its definition is potential of hydrogen ion in a solution. So pH always scales from 0 to 14. It can never be less than 0 and it can never be more than 14. So this is the range of pH, and in this range we measure the pH. So how it is being measured, or what is the meaning, or how the pH depicts about the solution? If you remember this graph or this diagram, in last lecture or in last course, irrigation water management, I have shown you this diagram while assessing the water quality, suitability for irrigation or not. So pH is the index of concentration of hydrogen ion in the water or in the solution. If it is not water, salt is added or soil is added or compost is added in the water. So then what will be the pH of water? If fertilizer is added in the, or fertilizer is dissolved in the water, then it is a solution. So what will be the pH of this solution? So every time it is measured as the basis of alkalinity and acidity. So this is the range of pH. It will always vary from 0 to 14. It means the middle point is 7. Most of the tap water is of 7 pH, or our distilled water is of 7 pH. Means neutral pH. Distilled water has the neutral pH, that is 7 pH. If pH goes below 7, our alkalinity increase. If pH goes below 7, our acidity will increase. If pH goes beyond 7, above the 7, the alkalinity of the solution is increased. So this, if it is water, so this way we can judge that if pH is 6, so water which we get through reverse osmosis or the bottled water, it is about 6 pH. And our sewage water is about 0 or 1 pH. It means that is highly acidic water. If we add salt and alkalinity of the water increase, the pH value increases. 8 means alkaline water. 8 to 9 is the alkaline water. This water is present most of the time when we take water from the canal or we take water from the deep borewell. As we go deep, the pH of the water will increase. So the alkalinity increase. And in our sea water is about for 13 and 14 pH water. That is, sea water is highly alkaline water. So this is the pH range. This is the depiction of pH range, or this is the inferences which we draw from the pH, that this is the quality of water. If the quality of water is acidic or alkaline, or the material which is added with water, it has certain acidity or alkalinity, which is measured as a pH of solution. So if it is soil, so soil has certain pH, but you cannot measure the pH of dry soil. Definitely the soil has the salts or has the elements which, when we dissolve or suspend in water, the pH of the water will be low and there will be the high acidity, or there may be some salts in the soil. When we dissolve this or suspend this solution water, this soil in the water, the pH of the solution will increase, means the soil is alkali. So again, the pH of the soil is the measure of acidity or alkalinity of a soil. Hydrogen ion concentration in soil solution is being measured. Again, here it is measured in solution. So what is the meaning of pH in soil? If the from 5.5 to 8 means 7 is neutral. Even in soil, if this soil is put in the water and we stir it in a soil solution or a soil suspension is being created, and if pH is 7, it means it is a neutral soil. And neutral soil is very best soil. But agriculture can be done very easily from the pH of 5.5 to the 8. So every time we used to say that the soil pH should be from 5.5 to 8 for a good agriculture practice. If our pH goes, if the soil pH goes below the 5.5 means soil is acidic. If pH is 3 or 4 means soil is acidic. If pH is 9 and 10 of a soil, it means soil is alkaline. So if our soil is alkaline, we have to correct it, and we need to apply some measures that pH will go down below 8. If our soil is acidic, again we use some amendments, some soil amendments to increase the pH, and it should goes up to the 6, so that the soil will be fit for the agriculture. Here I want to leave a question for you. The question is, what is the pH of petrol? You know, petrol which we use for the ignition of our vehicle. कार हम चलाते हैं, मोटरसाइकिल स्कूटर्स हम लोग चलाते हैं, and we use petrol as a fuel for our vehicle. The question is, what is the pH of petrol? This question I am leaving for you. You can read it somewhere, and in next webinar we will discuss this question. Soil, what is the importance of soil pH? Why we are always bothering that soil should be of this pH? As you have studied in previous courses that there are 16 elements which is regarded as the essential elements. These 16 elements or 16 crop nutrients are required by the crop for their growth and development. 3 are the basic: hydrogen, nitrogen and carbon. No, not nitrogen, hydrogen, oxygen and carbon. So this hydrogen, oxygen and carbon are the basic elements which is required by the plants for their growth and development in a larger quantity. But these 3 are available in nature and available to the plant as a free. Water is available, hydrogen, oxygen and carbon. So carbon is available in atmosphere in form of carbon dioxide. Oxygen is available in carbon dioxide and in water also, and hydrogen is available in water. So these 3 plant takes in abundance. Then 3 major nutrients, nitrogen, phosphorus and potassium. Then 3 secondary nutrients, sulfur, calcium and magnesium. Then these are the micronutrients: iron, manganese, boron, copper, zinc and molybdenum. One chloride is also, but it is not mentioned here in this figure. So these 16 elements are required by the plant. So 3 are available through water and air, but rest 13 elements plant takes it from soil. These elements are present in the soil in larger and smaller quantity, whatever it is, but it is present in the soil. Root needs to absorb these elements. These elements are present in the soil, and when soil is moist, these elements are available in the solution, means these are available in the water in form of solution in ionic form, and then in ionic form it is absorbed by the roots. So if soil has certain pH, So this pH either can help the absorption of these nutrients or can restrict the absorption of nutrients. So if pH is not neutral, it is more alkali or more acidic, the availability of the nutrients in the for the plant is restricted, because of the pH the nutrients are bind with certain other elements or other chemicals and it becomes unavailable. So this graph will tell you if the pH of soil is 7, this nitrogen is available to the plant, but when pH goes below 6, the availability of nitrogen going down, the pH below 5.5, the availability of nitrogen goes down drastically. In the other side, nitrogen is available to the plant up to pH 8. When pH goes beyond 8, the availability of nitrogen goes down, and at the pH more than 8.5, the availability of nitrogen goes down drastically. Like phosphorus is also available readily in a neutral soil or between 6.5 to 7.5 pH. Phosphorus is available, but from 7.5 to 8.5 or 8.7, the availability of phosphorus decreases, but beyond 8.7 pH again the phosphorus is available, and this phosphorus will be available to the plant even in the highly alkaline soil. Third important nutrient is potassium. Potassium is available at 6 pH. Below 6 pH the availability of potassium decreases. Above 6 pH potassium is available, and potassium is available up to the highly alkaline pH. The same thing is with sulfur. The sulfur availability to the plant decreases below 6 pH, but the sulfur will be available to the plants above 6 pH up to the highly alkaline soil. See the calcium is available at 6 pH. Even at 6.7 pH calcium is available. At 7 pH calcium is available to the plant. Even up to the 8 or up to the 8.5 pH calcium will be available to the plant. But when your soil become more alkali, the calcium availability to the plant is decreasing. Magnesium is available at 7 pH and 7.5 and at 8.5 pH. If soil is acidic, pH goes down below 7, the magnesium availability is decreasing. Below 6 pH, the magnesium availability is decreasing very drastically. So this is up to the secondary nutrients. When you come to the micronutrients level, you can see iron is available to the plant at acidic pH up to neutral pH, but in alkali pH of soil, iron availability to the plant is decreasing. Magnesium is also available in acidic pH, boron is also available in acidic pH, copper and zinc is also available in acidic pH. But when pH will be alkali, the availability of iron, manganese and boron, manganese, copper and zinc is decreasing. And beyond 8.5, this iron, manganese, copper and zinc's availability is decreasing drastically. In alkali pH, boron availability is very less, but when again soil is become more alkali, the boron will be available. The condition with molybdenum that molybdenum will be available in alkali pH from neutral to alkali pH, but in acidic pH molybdenum will not be available. So here if you see this graph, that this will tell you what is the impact of soil pH in the nutrient availability to the plants. If we do our agriculture in neutral pH soil, that is from 5.5 to 8 pH. This is good for agriculture because the pH of soil from 5.5 to 8 pH, here you can see from 5.5 to 8 pH, all the nutrients are available in good quantity, or all the nutrients are available to the plant easily. So here we can see if it is 5.5 to 8 pH, that is a near neutral soil, because neutral we cannot say, neutral means 7 pH. If it is 6.9, that is acidic. If it is 7.1, it is alkali. So near neutral soil means the near about the neutral range of soil. If we do agriculture in the near neutral soil, all the nutrients will be available to the plants. If we do our agriculture in acidic soil, the micronutrients will be available to the plant, but major nutrients deficiency will be happening in the plants. The plant will show the deficiency of major nutrients, while the micronutrients will be available to the plants. If we do crop cultivation in alkali soil, the major nutrients will be available to the plant, but micronutrients will not be available to the plant. So it is, the plant will show the deficiency of trace elements. So this is the importance of pH, and this is the reason why I am telling you that soil pH is very important for our agriculture, because 16 elements are required by the plants for their growth and development, and all elements are available to the plant in near neutral soil. If pH is highly acidic or if pH is highly alkaline, even the nutrients are present in the soil, it will not be available to the plant. So this is the main reason. Suppose we are doing agriculture in alkali soil. Every time we face a problem that we apply NPK or potassium, magnesium, sulfur also for the crop growth, still we are not getting good crop, and our plants are showing micronutrient deficiencies. If a farmer is worried that their plants are showing micronutrient deficiency, he has taken a soil test. In a soil test, the soil analysis told that these are the level of nutrient in your soil, and if when you see the soil test report, these micronutrients are present in the soil in a good quantity, still plant is not taking that nutrient. Then you come to see the soil pH in the soil test report. If the pH is alkaline, so immediately we come to know that though the soil test report is showing that the iron, magnesium, manganese, copper, zinc, it is available in the soil in a sufficient quantity, but still plant is showing the deficiency because our soil is alkaline. So macronutrients plants are taking. The nutrients are available in the soil, but because of the pH, plants are not taking it. So this is the reason that plant is showing trace element deficiencies, but the nutrients are present in the soil. Then what will you do? The question is, our soil is alkaline, nutrients are present, even micronutrients are present in our soil in sufficient quantity, but soil is alkaline, plant is showing trace element deficiencies. So what will you do? This answer of this question will be discussed in the webinar session. So this is the importance of pH. We should measure the pH, and then we can take the decision that what is the soil pH and what we need to do for this soil. So pH is measured by the pH meter. Definitely if we want to measure the pH, some instruments are required. So there are two instruments, two things. One will tell you exact pH. The another method will tell you the near about pH. There is one more method, third method, which I will tell you in this presentation, that will tell you only that the solution or soil is acidic or the soil is alkali. That's all, or neutral. The third method even will not give you the idea that how much acidic the soil is. The third method will give you the idea, yes, soil is acidic or soil is alkali. The one method, that is pH paper, it will give you the idea of acidity and alkalinity and about the range. Not exact, but it will tell you the range, that the pH is near about this. But this digital pH meter, this both digital pH meter will tell you the exact pH value of the soil or exact pH value of the soil solution. So these both are the digital pH meter. This photograph is of digital pH meter. This is a digital pH meter having electric motor and current and everything. This is electrode, because it pH meter, this electrode, even here also there is an electrode, and this is a chemical. So some chemical reaction occurs and it changes the color. This is pH paper. So the first photograph is pH meter. Here it is also written as pH meter. This is lab grade pH meter. This is portable pH meter. Both pH meter will give you the exact amount of exact value of the pH. Third is pH paper. pH paper is a yellow color. It is a strips. It is 2 strips of pH paper. So in one bundle there are so many strips of pH paper. It is a yellow color paper. It is a chemical. When you put this paper in the solution, some chemical reaction occurs and this paper will change the color. So when this paper will change the color, you just match the color with the value which is written over the first leaf of the pH paper. By matching the color, you can judge that pH is about 9 or pH is about 10 or pH is between 9 to 10. This way you can match the color and take the value of pH. If you measure the pH through pH paper, the pH paper will tell you the value is between 9 to 10. But the same solution, when you will measure the pH through pH meter, it will tell you the exact pH. It is, for example, it is 9.3. So the pH meter will tell you. So this is lab grade pH meter. This is portable pH meter. Electrode is available in lab grade pH meter also. Electrode is also fitted in this portable pH meter. And before using the pH meter for measuring the pH, it should be calibrated. So first it should be calibrated, then go for the pH measurement. So this is the calibration of pH meter. So pH meter is calibrated with the buffer solution. So we have two buffer. One is a distilled water that is having pH of 7. Another is the acidic solution having pH of 2. So how we handle this pH meter? This is the electrode of pH meter. Even here the electrode, so you have to dip it with a buffer solution, then in a ionized water, then again in a buffer solution, then again in a ionized water. Here also this electrode is every time need to clean with ionized water. So select the pH mode. What you will do? You will select the pH mode and then at 25 degrees centigrade. So just temperature knob put at 25 degrees centigrade, select the pH mode and adjust the calibration knob to read 100%. So rinse the electrode or wash the electrode with deionized water and then dry it with a tissue paper. Then put that electrode in a solution which you know that its pH is 7. That is a buffer of 7 pH. Buffer solution of 7 pH. So you put the electrode in the solution of 7 pH and then adjust. First you wait that reading should be stabilized, because when you insert the electrode in the solution, the digital reading it is changing every time, but when you wait for some time then it will be stabilized. So you have to wait to stabilize the reading, then the display, because you know the pH, the solution of the pH of the solution is 7, you know it very well, it is a buffer solution of known pH. So you adjust the pH at 7, then remove the electrode from the buffer, again wash the electrode with deionized water, dry it with a tissue paper, then this dried electrode, next time you put this electrode in another buffer solution of known pH having pH value 2, that is 2 pH value buffer solution. So this time this electrode should read reading 2. So again you wait to stabilize it and you just adjust the calibration 2 at 2 pH. So this way your pH meter is calibrated. Then after the calibration of pH meter, third time you can put this electrode in the solution where of which you want to know the pH. But this buffer solution, it is available in the lab and it can be reused. So in that container you don't pour the solution in the another container, you just put the electrode in the same container where this or in the same bottle where this buffer solution is available, and again you cap it so that this bottle can be reused for the next time. So the calibration of this pH meter is required every time. So when you want to measure the pH of your soil or the pH of your soil solution, first you calibrate this pH meter with these two known buffer solutions. One is pH of 7 and another is pH of 2. After the calibration, you put this electrode in the solution, in the given solution, and read the pH. Even the portable pH, you on this, temperature is adjusted at 75 degrees centigrade. Then this electrode is put in the buffer and pH is adjusted. And then once you calibrate it, then you can carry it to your field and you can do some readings, and after that next day when you return to the lab, again the calibration is required. And this is pH paper, no calibration is required definitely, but it will give you the idea, not exact pH. So this way first you calibrate your pH meter, then you measure the pH. So how you will measure the pH? You have a soil. Soil pH, that I will tell you later. So this is the calibration. This is the calibration that you calibrate your pH meter with two buffer solution, one is of 7 and one is of 2. After calibrating, that I have already explained you, after calibrating you need to measure the pH of the given solution. So again the knob is adjusted at 25 degrees centigrade. Then the electrode is washed with deionized water, and then electrode is put in the sample which we want to test, and then read the pH of the solution. Again here the care should be taken when you pour the electrode in the solution of which we want to test the pH. Again in the display the pH reading will vary some, so wait to stabilize the reading. When the reading of the pH meter is stabilized, then you take the reading, and again after taking the reading you wash the electrode with a deionized water and dry it with a tissue paper, then keep it close. So this way it is being measured. If we want to measure the soil pH, we take 10 gram soil sample of a dry soil. So when we take sample from the field, in our lab we just mash it and sieve it. It should not have any stone or any gravels or any grass or any root part. and it is mashed. So first we take the soil sample in our laboratory, we mash it, seal it and dry it. After all, we want to put the water, but to make the ratio correct, dry sample is required. So 10 gram dry soil sample is taken into 50 ml beaker, and a soil suspension is, we need a soil suspension because soil is not dissolved in the water, soil is suspended in the water. So add 25 ml of distilled water in the beaker. So 10 gram soil, 10 gram dry soil and 50 ml distilled water. So a ratio of 1:2.5 suspension is created. So this is the standard practice, thus 1:2.5 suspension is required. So then stir it for 5 minutes, then keep it for half an hour. Again stir it and then put the electrode of pH meter in the beaker for pH reading. So this is the pH of soil suspension, or we can say this is the pH of soil solution. But the solid particle of soil will not dissolve in the water, it is suspended in the water, so this is called as soil suspension. But the elements or the chemicals which are available in the soil, it is dissolved in the water, and that will tell you the pH. This is the reason 10 gram soil, 25 ml distilled water, we stir it for 5 minutes, then keep it for half an hour, so that the reaction will take place, and which are the materials or which are the elements are bind with the soil particles, that will dissolve in the water. Definitely particle will not dissolve, but the chemicals which are present in the soil, it is dissolved in the water, and then the soil solution will tell you the pH, which is due to the chemicals which are available in the soil and which is dissolved in the water, due to which the pH, there will be some pH reading. And solid soil particle will be suspended in this water. So this is the soil pH, how we measure it. We can measure the soil pH through pH paper. So these are the strips of pH paper. This is the book. This is a book. So at the top the color chart is given and the strips, वो जैसे पेपर सोप मिलता है ना मार्केट में, उसी तरह से बहुत सारी स्ट्रिप्स इसके अंदर हैं. तो each is, you can take the strip of pH paper, hold it from one side, another side put it in the solution, some chemical reaction will occur and it will change the color. So if it is acidic, the color will be about red. If it is alkali, color will be blue and violet, and in neutral pH it will be green color. So this reaction, this color changes is because of the chemical reaction, because this pH paper has certain chemicals. Certain chemicals are available in the solution also. So because of their reaction, the color changes. When you take it out, then you match this color with the color chart. So this color chart is available with the pH paper. Here you can judge what is the pH of your soil solution. One more test is available which can tell you only where soil is acidic or alkali. You again make a soil suspension in a beaker, then add vinegar in that solution. If the bubbles are available like this, the solution will be alkaline. If you add vinegar and there is no bubbles, then you may, in the same container you don't add baking soda, you throw that container. In another container again you make a soil solution with distilled water, soil suspension with distilled water. In next container you add baking soda. If the bubbles are available, the soil is acidic. So this way pH of the soil means acidity or alkalinity of soil is tested. Here in our agriculture waste management, we have converted our waste into compost. So definitely we want to know the pH of compost. The procedure is same, and the effect of the pH on soil or on plant is same as I have explained it to you for soil. Because if compost is of acidic pH, you are adding this compost to your soil, means you are converting your soil with acidic pH. So what are the consequences are available for acidic soil? That will be the effect like this. That will be the effect if you apply acidic manure to your field. This will be the effect. So to know the pH of your compost is very important, and the procedure is same as we have measured the pH of soil. pH of compost is also measured through the pH meter or through the pH paper. Spread the compost in a thin layer in a pan and dry it for 24 hours at 105 to 110 degrees centigrade. Then measure 5 gram sample, 5 gram oven dry sample, add 25 ml distilled water, stir it for 5 seconds, then wait for 10 minutes, then measure the pH with pH paper or with calibrated pH meter. So pH of the compost is being measured. These are the methods of measuring. This is pH meter. This is the calibration of pH meter. This is the method of measuring pH. This is the making the suspension of soil or suspension of compost, and then you measure the pH. So this practical exercise you need to do in your practical notebook with the diagram and with the procedure and with the hypothetical example also. And this is the learning outcome that today we have understood about the pH. We have understood the importance of soil pH also, and here we have known that here we have understood that what are the instruments to measure the pH and how the instruments is calibrated and handled, and the method of pH estimation of soil and of compost. So this is our today's learning outcome. We have a book. The book is method book for analysis of compost. This is Federal Compost Quality Assurance Organization. It is from Germany. Thank you very much.